Making a familiar in Isaac is a combination of making what is essentially a passive item and what is essentially a friendly enemy. In this tutorial, I'm going to be recreating Brother Bobby as friend Frankie. Very simple, it'll just shoot every 10 game ticks, which is 3 times a second, and for 3 damage. Okay, let me familiarize you with the ANM2 that I'll be using. It's identical to Brother Bobby's ANM2, except I removed some of the animations to keep things simple. It's going to make Frankie here shoot a little different than Bobby, but that's alright. There are 4 animations here, 1 for the idle animation and 3 for shooting. You'll notice there's an up and down facing attack animation, but only a right facing attack animation and not a left one. We're going to flip the sprite of the familiar using code later, so we don't actually need a left facing animation. Alright, to start, let's first define the familiar's item in items.xml. Go to your mod's content folder and create items.xml. I've already set up the structure of the items.xml here, so let's just define the familiar. Alright, first open a new tag. When defining an item, you usually type passive, active, or trinket here. For familiars, it's pretty similar, you just type familiar. And the rest of this is pretty much identical to defining a passive item. I'm going to start with the name attribute, which will be friend Frankie. Then the description, which should be the same as Brother Bobby and Sister Maggie because it's essentially the same item. So description equals friends till the end. I'm going to set the quality to 1 because that's what the other ones are. And these next 2 attributes are the important ones. First, like how stats are, familiars are given through a cache flag. Instead of reevaluating every item every frame to see what stats the player has, the game keeps a cache and only updates the cache when explicitly told to do so. A cache meaning just stored data that we intend to use later. The cache flag for familiars is familiars with an S at the end, so type cache equals familiars. Alright, the last attribute I'll add are some tags. I haven't really gone over tags in previous videos because they're quite straightforward. There's a list of them in the community documentation for items.xml, which is linked in the description. But I'm going to be adding 4 different tags here. So first, I'll create a tags attribute. Then I'm going to add the following tags with a space between each one. First is baby, which will allow this to contribute towards the conjoined transformation. Second is offensive, which allows Tainted Lost to be able to find this item. Third is summonable, which allows this item to be summoned by Lemageddon. And lastly is monster manual, all one word, which lets this familiar be summoned by the item monster manual. Alright, to close up that tag with a slash and a closed angled bracket, and now we have to make the entity for the familiar. Again, familiars are a combination of an item and an entity, so go back to your content folder and create entities2.xml. Here in my entities2.xml, I've again already set up the skeleton of the file, so we can jump straight into making the entity. There are not a lot of required attributes here, so it's pretty straightforward again. Open up a new entity tag, and first set the name of the entity. It's going to be friend Frankie for me. Next, we're going to define the ID of the entity. Familiars have an ID of 3, and this is going to be a variant of the familiar entity. So put a 3 here for the ID, and don't worry about setting a variant attribute, as the game will do that automatically. Next is the ANM2 path. The root up here is gfx/, and that's where I put the ANM2. So I'll just type familiar friend Frankie, the ANM2. Alright, I'm going to create a new line so that this can stay readable. Now I'm going to add a tags attribute. Like items, enemies can have tags that define specific behaviors. I'm just going to be adding 1 tag, which is can sacrifice, which lets friend Frankie get sacrificed by sacrificial altar. The next thing I'm going to do is set the size of the shadow for Frankie. I'm going to set this to 11, so shadow size equals 11. This can be anything you want, just set it to what makes sense for your familiar. Alright, lastly, we need to set Frankie's friction so that they can actually move around later. So just do friction equals 1, and then close up that tag. Hit save, and that's actually all you need to do for creating a familiar entity. And now we have to use Lua code to give it to the player when they pick up the item. Alright, I am inside my main.lua now with the mod variable already created. And let's define a few new variables. First, let's make a variable called itemConfig, which is equal to isaac.getItemConfig. The itemConfig lets us get information about our item, and we're going to be using it later. Alright, let's create some new lines, and now let's define some constants. Remember, constants are just variables that we don't intend to ever change. First, get the ID of the item for friend Frankie. So local item underscore ID equals isaac.getItemID by name, and within those parentheses, do quotation marks and type the name of your familiar as defined in the XML. So for me, that's going to be friend Frankie. After that, we need to get the config for our item. The config for our item holds a bunch of information that we already defined in the XML, but allows us to access it in Lua. We'll be using this later, so for now, type local config underscore Frankie equals item config get collectible, and then the ID of your item, so item underscore ID. Oh, thanks, Malwarebytes. How did I know that was gonna happen? Like before recording this, I'm like, it's definitely gonna pop up. Alright, next we have to get the variant of the familiar entity. To do this, type local familiar underscore variant equals isaac.getEntityVariant by name, and then the name of the entity as in entities2.xml, so friend Frankie. We already know that Frankie is a familiar, so we don't need the entity type, just the variant. We're going to create some new lines, and below that, let's make a new variable called local shooting underscore tick underscore cooldown, and set that to 10. There are 30 game updates, or ticks as I'll call them, in 1 second, assuming the player isn't lagging beyond belief. So we're going to use this variable to make the familiar have to wait 10 ticks before it can shoot again. Next, we'll define how fast the tiers move. So create a new line and do local tier underscore speed equals 10, with 10 being a relatively fast move speed that's similar to the default move speed for player tiers. Alright, after that, let's define the scale of the tier. The scale is essentially multiplied by the default size of the tier. So just do local tier underscore scale equals 0.8 to get a slightly smaller size for the tier. And lastly, we'll define how much damage the tiers will do. Local tier underscore damage equals 3. Alright, with that out of the way, we have to make a callback that'll hook into MC underscore evaluate underscore cache, so that we can give the player the familiar whenever the familiar's cache is reevaluated. So to start, do function mod evaluate cache, or whatever you want to name it. And then an argument for the player whose cache is being evaluated, which I'll name player. Make sure that's closed, and like I've done in the previous video, I'm going to use a Lua type annotation to tell Visual Studio Code that this argument here is going to be treated as an entity player. So that'll give us autocorrect for methods and properties on the entity player. If you haven't seen the mod structure tutorial where I go over Lua type annotations, please check that out by clicking the button in the top right corner of the screen. Remember that you'll need the Visual Studio Code plugins currently on screen to actually do this. And also remember that this part is completely optional, so if you aren't using Visual Studio Code, do not worry. So directly above the function, do -- at param player, or the name of the argument, entity player, which is the type of object it will give us autocorrect and suggestions for. Alright, close that function. And inside of it, let's actually give the player the familiar. We're going to add an extra argument when hooking into MC underscore evaluate underscore cache that will make this only run for the familiar's cache flag, so we don't need to check for that in here. For now, we're going to define a few variables inside this function that we'll use to give the player the familiar. Dude, Malwarebytes, leave me alone. Oh my god. Oh my god! Anyway, first we need to get the player's effects. This is an object, like how the item config is, that gives us information relating to the effects the player has. For example, the function we'll use from this object will tell us how many collectible effects the player has for our items, which are obtained by things like Lemageddon wisps. So do local effects equals player get effects. Then on a new line, we'll store the amount of Frankies the player should have. Do local count equals effects get collectible num, then the item ID of your item. So item_ID. This will get how many of the item the player has without actually owning the item, such as Lemageddon wisps. Then we're going to add to that number with the amount of Frankie items the player actually owns. So do plus player get collectible num item_ID. If the player has 2 Lemageddon wisps for this item, this will return 2. And if the player has 1 copy of the item and 1 wisp of the item, this will also return 2. Hopefully that makes sense. Now, before we give the player the familiar, we need to get an RNG object. This will define the familiar's init seed, which is a unique number usually used for RNG-related operations. Modders usually use the init seed as a way to distinguish unique familiars, so it's important to make sure this is unique. You may think to use the RNG object provided by player get collectible RNG, but we can't do that. You see, player check familiar, which is the function we're going to use to give the familiars to the player, is slightly bugged to where it won't actually advance the seed used by the RNG for each familiar. Essentially, this means that every time this RNG is used to spawn familiars, each new use of it will provide the same init seed, which can make it hard to distinguish the familiar from others if you need to do that. Because of this, a good practice is to instead create a new RNG object with a unique seed, and then use that for the function later on. If that doesn't make much sense, don't worry about it. I'm sure it'll make more sense as I actually do it. So to start, let's create a new line and type local RNG equals RNG, which creates a new RNG object. Then we'll set the seed of the RNG object to a random number generated using the global function random. So do local seed equals random. And as a refresher, if you haven't seen the other videos, the seed of an RNG object dictates what results you'll get when getting a random integer or a random float from the RNG. This random function here generates a number between 0 and 2 to the power of 32, inclusive on both ends, which is a pretty big number. The issue with this is that if you provide an RNG object with the seed of 0, the game will instantly crash. So on the astronomically low chance that random provides a 0, it's a good idea to use the math.max function to make it provide a 1 instead. If I wrap random within math.max like this, with a comma then a 1, Lua will return the number within these parentheses with the highest value, which will return either random or 1 if random returned a 0. Again, the chances of you getting a 0 is very, very, very low, but there's absolutely no reason to not do this. Alright, we're almost done with the RNG shenanigans. Under that variable, set the seed of the RNG object. Do RNG set seed, and then add the seed integer. And there's actually a second variable here called the shift index, as you can see right here. This is a very weird argument. It's a little unclear about what it does, though the Repentance developer and Antibirth creator _Kilburn has stated that it determines the parameters of the RNG to be used. That's a little vague, but basically the shift index will determine what numbers the RNG's seed advances to. So a different shift index will give you a different result, even if you're using the same seed. The game sets this to 35 in most instances, so you should do this too. To avoid using magic numbers, which are just random numbers in code with no clear meaning, I'm going to go up to the top where my constants are and add a new one, which will be local RNG_shift_index equals 35. If you're unfamiliar with why I am naming the constants using this format, it is because I want to be able to read a constant and immediately know that it's a constant. If I name my constants in this format and only name my constants in this format, it allows me as the reader to immediately understand my code's intention, which is very important. All right, add RNG shift index here and create a few new lines. Now we're going to use player:check familiar. The first argument is the entity variant of the familiar, so familiar_variant. The second argument is the amount of familiar that this player should have, so count. Next is the RNG object we just made, so RNG. And finally is the config for the item. This is used by Sacrificial Altar so that it knows what item to remove from the player's inventory when the familiar is sacrificed. So do config_Frankie. Oops, I mistyped RNG. Alright, that's all for the cache evaluation callback. Under that function, let's hook it into MC evaluate cache. Do mod add callback, and then mod callbacks.mc evaluate cache, then the name of your function with a dot instead of a colon. And then finally, we're going to specify which cache flag that this callback will only run for. So cache flag.cache_familiars. That's all you need to know to actually give the player the familiar. The rest of this tutorial will teach you how to check the player's aiming input and handle following the player. Alright, create a new callback, a few new lines under this. I'm going to name it function mod handle init. And this will hook into MC familiar init, which provides the familiar as the first argument. Put familiar in this parentheses here, or whatever you want to name it. We're going to specify this callback to only run for our familiar entity variant later. I'm going to add another type annotation here so that Visual Studio Code recognizes that this variable represents a familiar. So do --param familiar entity familiar, with familiar being whatever you named the argument here. Alright, create a few new lines and close that function. Within this function, we only need to write one line of code. The familiar will already be doing the float down animation when it spawns, since that's the default animation in the ANM2. So we don't have to worry about that here. The only thing we must do is register it with the game as a follower. So do familiar add to followers. This allows us to use a function that makes the familiar follow the player, and also tells the game what familiar to follow behind for familiars that are always at the end of the follower train, such as the key pieces. And about the follower train, followers will follow the player in an order based on a priority value. Unless you're using the script extender REPENTOGON, you can't actually change the priority of your follower. There are some hacky ways to force your follower to have a certain priority, where you manually set the parent and child of the player's other followers, but I won't be doing that in this tutorial as it can cause issues. I will link REPENTOGON in the description if you're interested in that. Alright, let's hook this into MC familiar init. A few lines under this, do mod add callback, mod callbacks, MC familiar init, then your function with a dot instead of a colon, and then the variant of the familiar entity, so familiar_variant. Okay, the last thing to do is to make the familiar shoot and follow the player on MC familiar update. After a few new lines, I'm going to type function mod handle update, and then familiar or whatever you want to name the argument. As I just did above, I'm going to use a type annotation to make VS Code treat this as an entity familiar object. So, a line above this, do --param familiar, or the name of your argument, and then type entity familiar. Close this function. And within our callback now, I'm going to store the familiar's sprite so that we can play different animations later. So local sprite equals familiar get sprite. Additionally, I'm going to get the player owner of the familiar by doing local player equals familiar.player. Next, I'm going to define a few variables that will help us control the shooting and animation of the familiar. First, I'm going to get the fire direction of the familiar. This isn't a vector and is instead a number that represents the general direction the player is shooting in. This number is also represented with the direction enumerator. So do local fire direction equals player get fire direction. Next, I'm going to make a variable that will store a vector representing which direction the tier of the familiar actually should shoot in. What I'm planning to do is to set this variable to a different directional vector depending on what fire direction is set to. Then under the if statements that check that, I'll actually shoot the tier if a direction was chosen. If that doesn't make much sense, just keep following along and I promise you'll understand why I'm actually doing it like this. For the direction variable, we don't actually need to set a value. Just doing local direction like this and not setting it to anything is the same as setting it to nil. We will check if it's nil before attempting to use it later. And that's how we'll know that a direction was set. Okay, under that, do the same thing with a variable called shootAnim. This will be set to a string that represents the name of the animation the familiar will switch to when shooting. And lastly, make a new variable called doFlip and set that to false. As mentioned earlier, there's no facing left animation for the familiar when attacking, so we're going to use the flip X property of the familiar sprite to make it look in the other direction as needed. By default, we're going to set this to false, and we'll set it to true if the familiar is shooting towards the left. Alright, now on to the if statement that actually configures these variables. As I said before, I'm going to check what direction the familiar is shooting in, then set the variables accordingly. So a few lines under this, do if fire direction.left, with direction being an enumerator which represents the different directions you can get from get fire direction. Add a then, and instead of having an end here at the bottom, replace this with an else if. In an if statement, the else keyword will run code as long as the original condition was not met. If we combine else and if into one word like we have here, we can have another condition check that will only run if the first condition did not return true. So go ahead and create a new else if statement for fire direction equals direction.right, and another one for fire direction equals direction.down. And finally, another one for fire direction equals direction.up, and then an end. Now, you don't actually have to use else if here. You could alternatively make 4 different if statements, because fire direction can only be one of these conditions at a time. But in this scenario, I find it neater to compact these if statements all into one. But you should do whatever you find easier to read. Now that we have the skeleton of this if statement set up, let's fill in the contents. In each block of code here, we will set the direction and the shootAnim. We only ever have to set doFlip to true in this first block here, since it's false by default. So in this first block, do direction equals vector -1, 0, which is a vector pointing to the left. Then a new line, and shootAnim equals float shoot side. And then finally, we're going to do doFlip equals true. In the next block, do direction equals vector 1, 0, which is right. Then shootAnim equals float shoot side. And don't set doFlip to true, as we want it to be facing towards the right this time. After that, do direction equals vector 0, 1, which is down. Then shootAnim equals float shoot down. And finally, do direction equals vector 0, -1, and shootAnim equals float shoot up. And again, do not set doFlip. Okay, now that we have everything set up, we can move on to actually making the familiar shoot. Create a new few lines under this, and let's create another if statement. This if statement will check if the familiar is not equal to nil, and will also check if the familiar's fire cooldown property is 0. We will be decrementing the fire cooldown property of the familiar every update at the bottom of this function, and if it's equal to 0, we'll allow the familiar to shoot. So do if direction is not equal to nil, and familiar.fire cooldown equals 0, and then. So first the game will check if the direction is not equal to nil, which it will be if direction is equal to no direction, which means you're not shooting. And then it'll check if familiar.cooldown is equal to 0. And if these are both true, it will continue. Inside this if statement, first we're going to define the velocity in which the tier moves in. This will be the direction variable we have here, multiplied by tier speed up here. and added to by the player's tier movement inheritance. If that last thing sounds really fancy, don't worry, it's just a vector you add to the tier's velocity that will change the angle slightly in the direction the player is moving. It's a very subtle effect, but all shooting familiars and the player have it. So I'm going to take this next part slow, since vector math is always scary if you're new to it. Do local velocity equals direction, and multiplied by tier underscore speed, and then added to by player : get tier movement inheritance, with the only argument being the original direction the tier is moving in. Because of PEMDAS, Lua will first multiply the direction by tier speed, and then it'll add the slight adjustment of the tier movement inheritance. Now let's actually shoot the tier. The player has a fire tier function, but we won't be using that, as we don't want to have any tier-related callbacks that should only run for the player and Incubus-like familiars running. We're going to simply spawn the tier using isaac.spawn. Side note, you could also use fire projectile, which is a function of entity familiar. I don't use that this time because there's no difference, and also I forgot. But just letting you know. Do local tier equals isaac.spawn, and then create a new line for each argument, as there are a lot of them. The first argument is the type of entity. So entity type .entity underscore tier, new line. Then the variant of the tier, so blue, which is the default. We have to set the subtype, which can just be 0. And then the position the tier will spawn at, so familiar.position. And then a new line, and give it the velocity we defined up here, so velocity. And then finally, set the spawner entity of the tier to the familiar. Close that up on a new line, and we're actually going to do one extra thing. I want to make the tier slightly smaller than normal using a tier's scale property. Isaac.spawn gives us a normal entity and not an entity tier, which is what we need for that. This is because of OOP, or object-oriented programming, which is way outside the scope of this video to explain, but just remember that entity tier is an entity, but an entity is not necessarily an entity tier. They are both separate things, but the entity tier inherits all the properties and functions of the entity. If that doesn't make sense at all, then that's okay. Just know that if you want an entity tier object out of this tier we just spawned, add a to tier at the end here. If this wasn't a tier, this would give us nil instead of the tier object. But we know it's gonna be one, so it's fine. Now we can set the scale of the tier and then the damage. Do tier.scale equals tier underscore scale, and tier.collision damage equals tier underscore damage. Next, we're going to set the fire cooldown of the familiar. Do familiar.fire cooldown equals shooting tick cooldown. Then some new lines, and then set the familiar's sprite's flip x value to do flip, which will either be true if shooting towards the left or false otherwise. So sprite.flipx equals do flip. And right under that, we're going to play the shoot animation we stored in shoot animation here. Do sprite play shoot anim, and then a comma, and then true, which will force it to play even if ongoing animation, such as the looped idle animation, is playing. Alright, make sure you have an end here, and we are very close to being done. Next, we have to add some logic that will set the familiar's animation back to the idle float down animation once it's done shooting. So create a few new lines, and do if sprite is finished, and then close that up with an end. Usually you're supposed to provide the name of the animation you want to check within these parentheses here, but just omitting that will check if all animations are finished. This might already be fixed by the time you're watching this video, but the Isaac API Visual Studio Code extension doesn't think you're allowed to do this, so it underlines this with yellow. I promise you can ignore that. It'll probably be fixed soon since I'm going to report it after I'm done recording this. Just take this as a reminder to always double check the community docs if you're confused in anything. Within this, just do sprite : play float down. Alright, last two things in this function. First, we're going to make the familiar follow the player around, and then we're going to decrement the fire cooldown by 1. The first part is easy, just do a few new lines and do familiar follow parent. As long as you've already run familiar add to followers, like we did in the init function here, running this function will update the velocity of your familiar so that it is correctly situated in the familiar train. And under that, let's decrement familiar fire cooldown. Do familiar.fire cooldown equals, and then we're going to use that math.max function from earlier again so that it never goes below 0. So math.max familiar.fire cooldown -1, and then a comma, and then a 0. And again, this will check between these two numbers, and whatever number is higher, it will return. Okay, the very last thing we need to do is actually hook the callback. Create a few new lines under our function, and type mod add callback mod callbacks.mc familiar update. Then the name of your function with a dot instead of a colon, so mod.handle update. And then the familiar entity variant for this code to run for, so familiar _ variant. All right, we finished everything, so let's go and test it in game. All right, give friend Frankie, and it works. That's all for this tutorial. If you have any questions, feel free to join my Discord server, linked in the description, or join the Modding of Isaac server, also linked in the description. Thank you so much for watching, and goodbye.